All right, welcome. Today we're tackling a statistical test with, let's be honest, a bit of a weird name, the Kruskal-Wallis Test. But stick with me because we're going to see how this quirky test acts like a brilliant judge in a really chaotic cooking competition. It's an incredibly useful tool, and by the end of this, you'll know exactly when and how to use it. So let's dive in. So, imagine this. You're a judge at a huge cooking competition. You've got dishes from a bunch of different schools, but the scores are, well, they're a mess. Some schools are pretty consistent, but others have these amazing, show-stopping dishes right alongside some total flops. So the big question is, how do you figure out if one school is actually better than the others, or if it's all just random luck? This exact problem is what the Kruskal-Wallis test was born to solve. You know, in a perfect world, all our data would look like those clean, neat graphs on the left, the kind you see in textbooks, right? But let's be real. Reality usually looks a lot more like the graph on the right. It's skewed, it's lumpy, it's kind of unpredictable. And here's the problem. When your data is messy like that, your standard everyday statistical test, they can get totally thrown off and give you the wrong answer. Okay, so that brings us to our first big idea. When our data isn't playing by the textbook rules, we can't use the standard playbook. We need a different approach, a special kind of analysis that's built for the messiness of the real world. Think of it this way. A standard test, what we call a parametric test, like ANOVA, is like a judge who demands that all the scores follow a perfect, symmetrical bell curve. It works beautifully when they do, but when the scores are all over the place, that judge just doesn't know what to do. That's when you call in the specialist, a non-parametric test. This specialist doesn't care about those strict rules, which makes it the perfect judge for our messy cooking competition. And that specialist, that hero of our story today, well, that's the Kruskal-Wallis test. Let's take a look at how this amazing tool cuts right through all that noise to find what's really going on. Okay, so here's the textbook definition, but don't worry, we're going to break it down. The most important part is that phrase rank-based. So what does that even mean? Well, if we go back to our cooking competition, this specialist judge doesn't just average the scores for each school, because that could be super misleading. Instead, this judge does something way, way smarter. And this is the secret sauce, the brilliant trick behind it all. The judge completely ignores the actual scores, the 8.9s, the 7.2s, all of it. Instead, they take every single dish from every single school and line them all up, from the absolute worst to the absolute best. Then they just assign a rank, first place, second, third, and so on. See, it only cares about where each score falls in the lineup, the rank, not the number itself. Now, any fair competition has to have clear rules, right? Well, it's the exact same for a statistical test. For our rank-based judge to make a fair call, there are a few conditions that just have to be met. So for the judge's ruling to be legit, we have to follow 4 basic rules. First, we're only judging one thing at a time, like just the taste score. Second, you gotta have at least 3 groups to compare, like our different cooking schools. Third, all the scores have to be independent. You know, one chef can't taste another chef's dish and then change their own score. And finally, the overall spread of scores from each school should have a roughly similar shape. You can't have one school with scores all bunched up and another with scores all over the place. It just makes sure it's a fair comparison. All right, theory is great, but let's see this judge in action. We're going to look at a real-world example from our source material and see how this actually plays out with real data. So, a researcher wanted to figure out if how much you exercise affects how well you deal with stress at work. They took 31 people and put them into 4 groups based on their activity level: sedentary, low, moderate, and high. So, in our little analogy, the groups are the activity levels, and the score is how well they could cope with workplace stress. After running the numbers through the Kruskal-Wallis test, the researchers got this number, a p-value of 0.002. Just think of this as the judge's final decision. A p-value is basically the chance that the results you're seeing are just a total random fluke. So a tiny number like this means there's only a 0.2% chance that the differences between these groups were just random noise. It's the judge slamming the gavel and saying, I am very, very confident that what I'm seeing here is a real effect. It's a significant result. And the final verdict was crystal clear. The study concluded there was a statistically significant difference between the groups. Basically, our rank-based judge lined up all the stress coping scores from best to worst and found that the people in the sedentary group consistently had their scores ranked way lower than the people in the moderate and high activity groups. It looks like exercise really did make a difference. Okay, this is all great, but the big question for you is, when do you actually use this thing? When do you call in this specialist judge for your own projects? Picking the right tool for the job is absolutely critical. So think of this as your decision-making cheat sheet. It's pretty simple. If you're comparing 3 or more separate groups and your data is beautiful and clean and follows that nice bell curve shape, then the standard one-way ANOVA is your go-to test. But if that data is messy or skewed or just doesn't follow the rules, that's your signal. That's your cue to bring in the specialist, the Kruskal-Wallis Test. So what this all means is you now have this powerful new tool in your toolkit for finding real, meaningful differences even when your data is far from perfect. I mean, think about it. You could compare student test scores across 3 different teaching styles, or see if a new marketing campaign works better than 2 old ones. The possibilities are really endless. So my question to you is, what messy, real-world questions are you going to answer?